harder to explain.
Right. Some of the ideas.
And interested in what other people were doing or what they were thinking, and very aware of it.
Without any further ado, I will introduce our wonderful chair for this evening. Dr. Rachel Clarke is an NHS palliative care doctor and writer. She's the author of 3 Sunday Times best-selling non-fiction books, including Your Life in My Hands and Dear Life, which was shortlisted for the 2020 Costa Biography Award, longlisted for the 2020 Baillie Gifford Prize, and chosen as a BBC Radio 4 Book of the Week. Her most recent book, Breathtaking, reveals what life was really like working on NHS COVID-19 wards during the first wave of the pandemic. And I'm delighted to say that she joins us here this evening. Rachel, welcome, and thank you so much for being with us tonight.
Thank you very much indeed. And I'm likewise delighted in a moment to be welcoming the newly appointed Dame Sarah Gilbert and Dr. Catherine Green, OBE, to this event. So Sarah and Kath are 2 of Britain's leading scientists. They're both based at Oxford's Jenner Institute, and they have led the extraordinary development of the Oxford AstraZeneca vaccine in record time, somehow also even managing to write a book about it. Sarah is a professor of vaccinology at Oxford University, and she specialises in designing vaccines against emerging viral diseases, so new diseases often that we've never seen before, while Catherine specialises in actually manufacturing those vaccines in large quantities for clinical trials. And their story begins all the way back to the 1st of January last year, when Sarah first read an article in an academic journal about 4 people in China who had been infected with a strange pneumonia. Within 2 weeks, her team had designed the vaccine that would become the Oxford AstraZeneca vaccine. And less than a year later, working very closely with Kath, the new vaccine had been meticulously put through its paces in clinical trials and rolled out across the world. And here we are now, just 18 months on, and over 500 million doses of the Oxford vaccine have been administered to people in 178 countries across the world, saving millions of lives from this dreadful new coronavirus. This book, Vaxxers, is the story of how they did it, and it is absolutely gripping. It's a nail biter from start to finish. So it's my absolute pleasure this evening to welcome both Sarah and Kath to this discussion. Absolutely delighted for as many people as possible to ask questions if you'd like to, and I'll try and include as many of those questions as we go through this discussion. So please just post them if you're keen to ask them something. Welcome both of you this evening.
Thank you. Very good to be here.
And thank you. Well, perhaps I could start with you, Sarah, just thinking back to the 1st of January last year. I mean, it seems unimaginable that a vaccine which perhaps typically would take 10 years to reach the point of actually being distributed and administered to people could ever be achieved in a 1/10 of that time. But you, both of you and your team have managed to do that. Did you ever think that was possible on the 1st of January last year?
Well, on the 1st of January, I wasn't really thinking about developing a vaccine that was going to be rolled out across the world. I was looking at a website that said there were some new cases of pneumonia and wondering what that might signify. It might have been something that just fizzled out very quickly. It might have been something that turned out to be a virus we already knew about, such as flu, for example, or even an adenovirus infection. The adenovirus is the virus that we use to make the vaccine. So I was, having seen that first report, I was going back and looking for updates, and it was becoming more and more clear that this was a viral infection. It was a novel viral infection, not one we'd seen before. Then we found out it was a coronavirus. And that was of interest because I'd been working on a vaccine against a different coronavirus, the Middle East Respiratory Syndrome. So a very similar virus, which has a spike protein on the outside of it. And we'd used the spike protein from the MERS virus in the MERS vaccine. And that had been in clinical trials already. So we had a template to work from, but we also have a technology that we use that is developed to be very adaptable. And we can use it to make vaccines against lots of different diseases, and have been planning to be able to use it against what the WHO were calling disease X. So planning for a new disease, we didn't know what it was, we didn't know when it's going to happen, but we knew we'd have to be ready to respond when it came. So the early questions were, well, is this disease X? Is it something we already know about? Is it, no, it's not, it's something new. Is it transmitted between people? That was another key piece of information. We didn't know that to begin with. What we did know is that the first people infected seemed to be associated with visiting a particular market where there were live animals being sold as well as seafood. And so there was the possibility that these people were getting infected directly from infected animals, and it wasn't going to transmit between people. And if that what did turn out to be the case, we wouldn't need a vaccine, because once they'd cleaned up the market, that would have been the end of it. Then we got the information there was human-to-human transmission. And of course, over time, the variants have adapted and become more transmissible. But we didn't have the very transmissible variants at the beginning. So it was a question of knowing that we had a technology that was suitable for use, knowing that this was a new virus, and just deciding to get started and see where it took us.
You make it sound so easy. Kath, what about you? Winding back, when did you first become aware of this pathogen and start to think, this is serious, I need to be involved? Perhaps a late night phone call from Sarah.
Well, that's right. Yeah. So I am not an infectious disease biologist. I'm a vaccine manufacturer, or a biological medicines manufacturer, shall we say. And so I've worked with Sarah previously on other projects, and my team have worked with scientists in the Jenner Institute quite significantly over the last 20 years, developing vaccines against diseases that they are working on. So Sarah knows that if she has a vaccine that she needs made, I am across the road and we see each other all the time. So she can call me and say, hey, we've got a new one. Can you make this? So Sarah designs it, and then I put that design into practice in a very controlled environment, because although these vaccines are quite easy to make in a laboratory setting, my job, of course, is to make them in such a way that they are suitable for use in humans for the first time. So a much more regulated and controlled environment. So Sarah called me 20th of January, email to say, hey, we're thinking about working on this new one in Wuhan. Would you be able to help? Do you want to have a meeting? I'm not very good at immediate replies to emails, so I think I replied the next day because I didn't have a sense of the urgency at that point. From that meeting on the 22nd, when we were quite relaxed, every day the situation got worse. Every day you could see cases going up. The media picked it up, and it then became a story that we were likely to have to do something, and therefore we needed to get as quickly as possible. So it started slowly for me, because it was a bit of a hypothetical. If this became a problem, what could we do? Do the first step, try and find some money. And then every day it became more and more urgent. So the pressure ramped as the project ramped.
Yeah, everything was exponential, including your sense of urgency.
Yeah.
Yeah. Sarah, when did you first start to think, actually, this is serious, this could be the big one?
I think that feeling grew during January. So from the very beginning, it was kind of thinking about, is this going to matter? And then always understanding that if we needed to make a vaccine against this virus, we should start straight away, but then it might turn out that actually we didn't need it. But it was still interesting to give it a try as a kind of academic demonstration project. That might have been all that we did. We might have ended up at the end of February saying, well, look, we made a vaccine quite quickly and we could have used it if it had been needed. But actually the urgency was growing because the numbers of cases were increasing, more people are going into hospital with the disease. And it was clear that we were going to need a vaccine to control the disease, and we had to go as fast as we could. And then we started thinking about how to accelerate everything. And that's mainly about starting each part of the process at the earliest possible opportunity and not waiting for all of the results from the previous part of the process, which is what we would normally do, because normally we're trying to make the most of the limited funds that we have available. So we would do a small piece of work, check that everything was good, review it all, and then decide we go on to the next, but which is a financially sensible approach, but it's not the fastest. So this time we just, as soon as we could, moved on to the next phase, got the results coming in. So everything was happening in parallel. That might have meant if something had gone wrong that we would have to stop and go back. Fortunately, that never actually happened. So we were able to go really quickly through all the different stages of manufacturing and getting permission for the clinical trials and then getting them started.
And I mean, it's really interesting hearing that description of the sort of early phase, January, February, March, because certainly from my perspective, sort of on the front line of the NHS, thinking vaccines were not going to exist for, you know, a decade probably, what we were very conscious of with increasing anxiety as we rolled through February was the apparent inertia in a lot of areas of the UK. And I'm not necessarily making a political point here, but there were a number of COBRA meetings that happened, that the Prime Minister wasn't there. We were getting twitchier and twitchier in hospitals about the cases that were rolling in, and actually the lack of, you know, anything practical like PPE, for example, that might help us in this situation. And what's very striking in that context is just the alacrity with which the pair of you and your teams really started ramping up the impetus to make this happen. And can you comment on that? Because it's not how I think we typically imagine science to work.
We do have a lot of clinical colleagues as well. So we weren't only relying on the press reports and the things that were being heard on the news. Yes, I think you would say, yeah, we had Andy and we have colleagues who work in the NHS in the Oxford hospitals. So we had access to your side of that too, which did also, I think, focus the mind somewhat. Yeah.
Yeah.
Yes, Sarah? Our colleagues
are
nudging us that this might be a biggie.
That's interesting. So did you have sort of infectious diseases experts who were bending your ear saying, look, what we're seeing clinically in China, it's spreading into Thailand, other countries, this is serious?
Well, we were getting information from them. We were just going as fast. Having decided to start, we just went as fast as we could. We were only going to stop when we either didn't have the money or somebody told us we didn't need it. And fortunately, neither of those, well, fortunately with the money, it would have been actually quite useful if somebody had said, oh, it's all right, it's gone away now, we don't need it. But clearly that didn't happen, so we had to carry on.
So tell me, Sarah, at what point did you have to start banging on people's doors, whether that was the government, the national funding agencies, or pharmaceutical companies, for the funding you needed to make all of this happen at the same time, essentially?
Well, right from the very beginning, I was having conversations with colleagues about, well, how do we pay for this? Because the research funding that we get.
20th of January, when she came to me, she said, can you help me start making the vaccine? I'm like, well, can you pay for it? Because that's my job.
Yep. Yeah, a lot of the funding we get is really for a very specific purpose, and we can't just do whatever we like with it. I was fortunate to have a little bit of flexible funding to do with general vaccine development and development of vaccines that would affect low and middle income countries, and this vaccine was needed across the whole world. So that was appropriate to use that, but I couldn't get very far with that. And then it was possible to do a funding application for UKRI. They put out a rapid response call, and I filled that application and we got some funding. But as soon as we got the funding, we knew we needed more funding. And then I was talking to other funding agencies about what we could get from them. And in the background to all of that, the government was forming the UK Vaccines Task Force, which once that had come into being, started to look at all the different vaccines that different companies and academic groups were making and decide which ones to invest in. So I had a very frustrating time in March and through most of April, desperately trying to raise the money, having got the first part, but knowing we needed more. And then eventually by the end of April, the Vaccines Task Force were able to provide us with funding that we could use to carry on with the clinical trials, which were expanding by that point. And so then the problem of raising the money became very much less. We did have to ask for further funds, but that was forthcoming as well because it was a big project and it was going well by that point.
But from January to April, you were having to make do with what you had and try and expand it in terms of funds.
Yep, apply for everything that we could. I spent a lot of time with one funding agency trying to basically repurpose some funds from one project to another project, and that eventually failed. We didn't manage to get agreement to do that. I spoke to the House of Commons Science and Parliamentary Committee and said that I needed money immediately, and they nodded and took that on board, and I didn't get any money. But then through the task force, which was in the background being formed, we did then get funding for the work that we needed to do immediately. It was always a scramble because as soon as we put together a budget, by the next day we'd added to it because we kept having to think of, the next phase and the next phase. So it was a very difficult project to manage because normally you'd have lots of documents that detail what the project plan is and what the chart for the timelines is and what the budget is, what each bit of it's going to cost. Well, we were just literally making this up as we went along. We worked with a large team of people who were very skilled and knew what we needed to do, but we needed to do it all very quickly. So there wasn't time to put together carefully approved plans and budgets. We just had to keep going and keep trying to bring in the money to support the work as we went.
And Kath, one of the things you mention in the book, which surprised me when I read it, was the fact that the one thing I think neither of you had really thought about when you imagined making a vaccine for disease X was that disease X might actually be on your doorstep and you would be living through the pandemic while trying to vaccinate the world against the pandemic. So can you just give us a flavour of what that was like?
I think that's right. So a lot of Sarah's work has been on outbreak pathogens, so pathogens which emerge and then exist in a defined geographic location. And so we had kind of been, I think, in the back of our minds, naively thinking that if disease X was a thing, we would go quickly to make a vaccine here in Oxford and ship it out to where it was needed, and that would be our cape wearing for the day, done our bit. So I think we were naive in that. We hadn't. It's obviously obvious now, but I think we hadn't really done that joined up thinking about how do you manage to manufacture vaccines or run clinical trials when public transport is collapsing, we can't get lunch. So one of the stories in the book is about some really good volunteers, philanthropists, donors who generously asked Sarah and the team, what do you need? How can we help? And I don't know, I guess a lot of our audience might be from Oxford, and we're up on the Churchill Hospital site, and if the university catering is not working, there is nothing to eat, there's no food. I had a week when I lived off mini cheddars and Bounty bars, because that was all there was in the vending machine, and then the vending machines ran out and there's no food. And so through generous donation, somebody asking how they could help, lunch was provided to the team. And that was hugely important. It was a morale boost, but it was a practical measure because it meant people actually focus on getting the work done that they needed to be done. And so that has to be part of our planning going forwards there. It's not just about how do we think about the actual doing of the science. It's about the actual doing of the science. Yeah. Got to look after the kids. Somebody's got to look after the sick and elderly grandparents. Somebody's got to get the PPE where we need it. All of that joined up thinking we could have planned for, but I just don't think we had. I don't think we realised this was what we needed to plan for.
So I need to ask you both an extremely serious question now. Did either of you at any point ever run out of loo rolls?
I had a postdoc who had gone to Tesco's and had seen there was lots of toilet paper and bought lots of toilet paper and brought it into the CBF and put it on the windowsill with a note saying, guys, help yourselves. We were all looking out for each other. And I think that was recapitulated across the country. Yeah, we were looking out for doing the shopping. So I think we were lucky enough to never have run out of toilet roll.
Yeah.
It's a joke about a sock, but I won't go there.
Someone has asked an interesting question, Isabel, which I'm guessing, Sarah, you may be best placed to answer. She asks, in the beginning, how do you go about getting a live sample of the vaccine, or do you even need one? Do you just build the vaccine design from a model of the spike protein?
We don't need the live virus. We don't need the pathogen itself. And that's one reason we can go quickly and we can work with an outbreak that's happening in one part of the world and make a vaccine in another part of the world. We just need to know the genetic sequence of the virus, of the protein that we want to use. And that was determined in China, and it was put onto public databases. It was made available so that everybody around the world could access that information. And we then just download that from a computer. And from that, we design exactly what we want to make. And we have that synthesized as a new piece of DNA. And we combine that with our viral vector, which is what we use to make the vaccine. So that's when we get the first DNA that's the whole vaccine. And we then turn that into an adenovirus and hand it over to Kath, who gets on with making lots of it so that we can manufacture it and get onto the clinical trials. So that is one advantage of what we call the platform technologies, which adenoviral vectors that we use are mRNA vaccines is another platform technology, DNA vaccines is another one. We don't have to have the pathogen itself, so we don't need high containment labs where you can work with these dangerous pathogens. We just need access to the database and a computer.
Let me ask you now about the role of AstraZeneca. So you know, typically a lot of people frame big pharma as the bad guys. You know, they're the people who want to make mega bucks on the back of people's illnesses. And I think the truth is obviously more complex. So Kath, what do you regard the role of AstraZeneca as being in all of this?
So we could not have done this without a major global pharmaceutical partner. I think, again, naivety perhaps at the beginning made us think that we could. Very early on with a colleague, Sandy, we had set up a UK manufacturing consortium. So we did have the ability to manufacture large amounts of the vaccine in the UK. And that was then built on by AstraZeneca to go even larger. But none of us really understood the complexity of, I think, even running these very large scale phase 3 trials. The logistics of it is enormous. And then the logistics of manufacturing global amounts of doses, billions of doses, is not something that can be done by an academic partnership, even with a small local manufacturing consortium. AstraZeneca immediately brought, well, funding, but expertise in delivering global scale logistics issues. They have databases and acronyms and words that we haven't even heard of that we need to understand in order to figure out how to make vaccine on 5 continents. And Serum Institute India, as well as being part of that package, being the world's biggest vaccine manufacturer, have been hugely important in us making vaccine at cost. And sometimes we do feel AstraZeneca got a lot of bad rap because they did sign up to our academic terms and conditions. You can make our vaccine, but it has to come with the caveat that it will be a globally available low-cost vaccine, and other pharmaceutical companies may well not have taken that on because that's a financial commitment that they have made. They deserve some credit, I think, some significant for what they've achieved.
I mean, there was a really controversial moment towards the end of last year when the Prime Minister referred to the fact that we only have vaccines because of greed and capitalism, which I thought was a bold statement. And it seems actually as though AstraZeneca and yourselves were doing this for the exact opposite reasons. I mean, is that naive of me, or do you think that's true?
No, we started work on the vaccine for public health. We want to protect people's health. A lot of the vaccines I've worked on in the past are never going to make any money because they're only going to be used in small quantities, potentially just to contain outbreaks. And they'll have to be manufactured and stored ready, but then nobody's going to make big bucks out of that. And it's the same technology now that we're using for all the millions of doses that have been made, and it will probably turn into billions eventually, because it is a technology that's suitable to do that, and it doesn't need very low temperature storage, which makes it easier to store and to ship around the world. But we weren't thinking of making money out of this, and AstraZeneca agreed to our terms that it would be produced at cost for during the pandemic and for low and middle income countries in perpetuity. and it's the major vaccine supplied to COVAX, which is the facility for getting vaccines around the world to all countries that don't necessarily have manufacturing facilities or the ability to pay for the more expensive vaccines. I think now 90% of the vaccines used by COVAX are made by AstraZeneca. At one point it was 96%. They have had some more donations from others now. So no, definitely not greed and capitalism, but it's all about protecting health.
Yeah, and I imagine people listening will be very, very pleased to hear that, and it probably reflects the vast majority of the population's attitudes and motives, you know, a year ago when this was all beginning. When you moved into the clinical trial phase, something which people increasingly, I think, started to chatter about as 2020 went on was the idea that somehow if you're doing things so quickly, you must be taking shortcuts. And what one of our participants, Ian Honeybell, asks a very appropriate question here. Just how do you mass produce a vaccine? Do you grow it? Does it take a finite amount of time? Or do you simply duplicate lots of it? Kath?
So this is exponential again. So I use I'm now a middle class professor at Oxford University. So I use a very middle class analogy, which is a sourdough starter. So I make in the clinical biomanufacturing facility up the hill, a small batch, about a pint of starter. So that's the very first time the vaccine has been made in quantity, in a quality that's good enough to go into a person. And that is itself the vaccine. You could use that to vaccinate people, but we don't. We split that off and we use that to seed larger batches. And then that can go on in a process of amplification. So you can take a bit of that larger batch and use it to seed an even larger batch. So all of the Oxford AstraZeneca doses which are going into arms today are direct descendants of that very first clone and very first pint of material that was made here in Oxford. We have just taken bits of it and used that to seed in human cells, which is the factory that grows the seed and then seed and then seed. And obviously, because that's an exponential, you can get to 1,000-litre bioreactor, which makes millions of doses very quickly if you seed and then seed and then seed. So it's an expanding train, and you can do that in multiple sites in parallel. So AstraZeneca are now manufacturing, and I think 20, is that right, Sarah? 20
yep.
So independent manufacturing sites in different countries, but it's all from the first original that we made here in Oxford.
Now that makes sense, but Vanessa Langston asks, how were you able to conduct the trials on the vaccine so quickly? Were any shortcuts taken? And that, I think, was certainly a fear some people had last year, you know, that somehow this can't be as safe as other vaccines precisely because you appear to be achieving its manufacture and testing at such pace. So Sarah.
Well, this comes from the fact that we're using what we call a platform technology that we'd already got a lot of experience with. So we made other vaccines with this technology. We worked out how to manufacture them, and we'd done clinical trials with them. So I talked about the Middle East Respiratory Syndrome vaccine, which is another coronavirus that had been in a clinical trial in Oxford. We'd started that in the usual way. It'd taken a couple of years to go through the process of getting the funding in place, getting all the approvals in place. We tested 3 different doses of the vaccine, starting low, thinking that's probably going to be too low, but we'll start with a low dose, and then we'll try a higher one, then we'll try a higher one. And we documented the reactogenicity after those different doses. So did people have a sore arm? Did they have a headache? Those kind of things. And then we took blood samples and we measured the immune responses. And we found that at the highest dose that we use, yes, we did have more symptoms after vaccination, but we also definitely had the strongest immune responses. So that was, I think, about the 12th clinical trial that had been done with this particular type of technology. So in our applications to the regulatory authority to do the clinical trials, we'd gone through the same process of filling in the applications to do it, It's kind of a template that you fill in. There's a lot of information you need to provide, but it's in a very structured format. So we've done that lots of times before. We've had the discussions and the approvals from the regulatory authority and from the ethical committee as well. Every document that we give to our volunteers has to be scrutinised and approved. But because we've done a lot of clinical trials that were very similar, we had templates for all of these documents. So we just had to tweak them slightly, and that made that part of it much faster. And then we were able to provide them to the regulatory authority and ethical committee, who were able to approve them quickly because it was so similar to what they'd seen previously. If we'd been starting from scratch doing something completely new, it probably would have taken 2 or 3 years to get to the point where we go in the clinical trial. But we really benefited from all the work we'd done on the technology previously, and all the work we've done in clinical trials of this vaccines made using this technology, because then it was just kind of, it was literally copy paste. It was and another one, the same approach, and everybody knew what they were doing. And we were then able to submit, because there was a pandemic situation, we didn't have to wait to have a complete dossier to give to the regulators. They very kindly agreed to start reviewing each part of the package as soon as it was completed. And that meant that by the time Kath's team had got the final quality control data on the vaccine that was made specifically for the clinical trials, they only had to review that last piece of information and could then say, yes, we give approval. So that made things much quicker. So it was based on years and years of previous experience in manufacturing and clinical trials with this type of technology.
So you were almost primed and ready to go. This moment was something that had years and years of planning behind it, essentially.
Yes. So we just tested the 1 dose this time, having tested 3 different doses previously. We knew that we wanted the strongest immune response we could get. We planned to test 2 doses of the vaccine, one after the other, and we started to do that because we saw that was giving us stronger immune responses. And then we started with young and healthy adults between the ages of 18 and I think 50 in the first instance. Was it 55 maybe? And then then only when we had some data from that population did we ask permission to extend it into older people. And we did that in 2 stages. So it's 55 to 70 years first, and then 70 years plus, and gradually recruiting people who had some health conditions, rather than being the super healthy young people. It was sort of more normal members of the general population were being recruited into the trials, because that's the population we need to protect ultimately. But that didn't happen all from the first day. It was done in a staged way, generating data, generating information, and then asking for approvals to go on to the next phase. But we did do it relatively quickly because we had so much experience. We'd used this vaccine in people over the age of 70 previously, this type of vaccine. So it wasn't something completely new.
So one of the most amazing moments in the book is your account of getting the first all-important efficacy data for the vaccine, so that the numbers that showed just how effective it was. And I will say nothing more about that, except that everybody is going to be biting their nails when they read those pages. Of course, we know that those data were very, very impressive indeed. And I guess something I felt when I read the book, I could feel some of the frustration and perhaps even distress beyond that point, when in many ways the vaccine started to be treated as something of a political football. So there were shenanigans in the States. Some commentators felt as though the Oxford vaccine was being smeared to some extent in the States. In Europe, we had President Macron of France essentially saying the vaccine was worthless. We had the Germans deciding whether or not it was actually something they felt was worth giving to an elderly population. All of this was going on, and it must have been unbelievably frustrating, to say the least, for both of you to find that suddenly your science and all your good intentions were being bashed around in ways you maybe never envisaged. Kath?
Well, we have quite thick-skinned scientists, so I think that it's not our job to be buffeted by that. And we had all, we talked amongst ourselves and decided the best response sometimes is not to get involved. It's not our fight to fight. It's our job is to get the information out there, make sure it's accurate, and make sure that it's available for people to then draw their own conclusions. We now see real world efficacy data, real world effectiveness, and Public Health England are reporting the lives saved and the hospitalizations prevented due to both vaccines, ours and Pfizer-BioNTech, and that's good enough for us, isn't it? Yeah, there are of course personal frustrations when you see in the newspapers, but scientists have quite tough skins normally. I think we all kind of collectively, didn't we, Sarah, decide to kind of just ignore that.
I guess this leads on to your motives for writing this book, which frankly seems like absolute madness based on the year you had last year. Why on earth you took on an additional project, I do not know. You must both be clinically insane. but in all seriousness, you talk in the book a little bit about your motivations, and there's one line which I've noted here, Sarah. You wrote, maybe what I've really taken on board is that science itself needs to be seen. What were you getting at there? Why do you think that is so important to try to achieve?
I think that's actually Kath's line in the book, but I'm happy to talk about it as well. So,
I'm so sorry. Well,
that's fine. So we were getting the sense from people that firstly they were concerned about the speed, and we've talked a bit about that and how that was able to be done, but we're still doing everything there very thoroughly. But also people had a sense that vaccines were being made by big pharma companies who were kind of sealed off from the rest of society and did their own thing and made lots of money out of it, and possibly weren't very open and honest about what was going on and didn't want to communicate and just expected everybody to turn up and roll up their sleeves and get vaccinated. And that's not who we are. We're two academics from Oxford. We work. We're always trying to communicate about the science that we do, because we have to teach as well as do our research. And we wanted to explain that this isn't something coming from some strange large company that won't tell you anything about it. And we will tell you about it. We'll tell you what's in it. We tell you how we made it. We'll tell you how it works. And we want people to understand, because if people have a good understanding of how this all came about, and how the vaccine works, I think they'll be very reassured about being vaccinated. And we wanted to try and put that story across.
And you tell a wonderful story, Kath, at the start of the book about at last getting to go away on a little camping holiday with your daughter last summer, only to overhear somebody talking about precisely these issues, very genuine fears that, this is that vaccines are dangerous, they're all about big pharma trying to make money from vulnerable patients, etc. And you kind of launch into a persuasion offensive, it sounds like. And in a way, is that a specific motivation for both of you in writing this book, that vaccine hesitancy is incredibly understandable? People are frightened about the idea of putting something foreign into their bodies, and perhaps by telling this story and showing the science, and also yourselves a little bit, who you are, your personalities, your ordinariness, in one sense, you could achieve something important and positive.
I hope so. It was that we're not hiding anything, and I mean that is clear from everything that's happened with the vaccine program. Yeah, so side effects are reported and discussed, and we have to approach those truthfully and honestly, and that there's this idea that scientists are these lonely, often male dudes working by themselves, and it's not how it is. We are a collaborative community. And yet trust is earned, and we as scientists can't assume that we can come in dogmatic and be the expert without that being a two-way conversation, without us explaining who we are and allowing people to know a bit about who we are, so that then they trust our expertise and perhaps then take seriously the data that we present and the nuance, and understand that science isn't always very simple. Needed in this book to find a way sometimes to take a longer form view of explaining quite complicated and nuanced situations, but with accuracy and honesty, so that you can see what we're up to. You can see what we're
Yeah. Well, one anonymous participant in this event has asked specifically about the very rare but important side effect of blood clots associated with the Oxford vaccine, and asks the question, are you now looking at how to mitigate the risks of attributed blood clots to the Oxford vaccine being administered? Is that something that you're working on in your labs? This person asks.
Well, there are a number of things going on. So the hematologists who first spotted these very rare events, which were so rare that they didn't happen in our clinical trials with tens of thousands of people. It needed to be given to a lot more people before we started to see it. The hematologists have been looking at it, understanding condition, thinking about how to best treat it and making that information widely known. And we're not directly involved with that, but the hematologists are doing a great job of communicating between themselves so that people get the best treatment possible if it does occur, and also helping to understand exactly what the phenomenon is from a clinical point of view. And then they communicate with scientists at AstraZeneca and ourselves about, and we're trying to understand the mechanism of this very rare adverse event. And that will give us the opportunity then to think about how we can avoid that happening at all. But until we understand exactly what is going on in this very small number of people, we won't be able to work out what we need to do to change it. So on the treatment side, that's leading the way. But on the new approaches to developing the vaccine, that's still an active area of investigation. It's being led by AstraZeneca with support from Oxford, and we will do all we can to get to the bottom of this and work out what we have to do about it. But it is going to take some time. It's a complex situation and made more difficult by the fact that it is so very rare.
Mm-hmm. You've touched on your desire to try and dispel a few of the myths around the process of science. If there's one word that sums it up in popular imagination, it's probably eureka, or the falling of an apple onto Newton's head, etc. And also, perhaps, forgive me if I'm putting words in your mouths, but trying to show a face of science which is not that very male, stereotypically boffin in a lab sort of doing their extraordinarily clever science. And that, were you consciously aware of writing a book that was showing a feminine view of science? Did you want to emphasize the fact that you were women in what is still a predominantly male world, although that's changing? And if so, why? Perhaps Kath.
I think we wrote it as ourselves, so I don't think that's a conscious decision. Some of our life, with friends and family and caring responsibilities, and some of that may be seen as feminine, but it would have been the same story if I had a Y chromosome. I would have done the same things. And I like to, it's a very team and collaborative effort, this. It isn't lone boffin story. There are still some times in science when it is a eureka moment, but this one, it's hundreds of people in a huge team collaborating and cooperating together, and it's been a great way to work. And if people can see that is another way to do science, that science is now often done in very large teams across international borders with very diverse groups of people with different skills and backgrounds, which is really how science is done now. It would be good if some of that is true. But then, yes, we all do have to go home and, stack the dishwasher, clean out the wasps' nests, and, feed the 10-year-old and homeschool them, because that's easy to do.
Yeah, absolutely. I mean, I think it's fair to say that a number of books written by eminent scientists, particularly sometimes those at the ends of their careers, do very much present themselves as, heroic figures on a pedestal somewhat, and I think it's very refreshing that both of you very emphatically write about yourselves as three-dimensional, ordinary human beings. However, that has not stopped you both, as I'm afraid you must be well aware. It's not stopped you becoming two national treasures, as exemplified by Sarah, your standing ovation in Wimbledon last week, which, you know, you looked slightly uncomfortable at as it unfolded. I sat there crying at the expression of gratitude that the public were giving you and your team for this incredible endeavour that is helping making them and the rest of the world safe. So you're role models now and your examples, and you have that gratitude from people across the country. And I want to know how that makes you feel, albeit perhaps as two private people.
Well, I mean, the standing ovation at Wimbledon was wonderful in a way. I would rather have not been filmed having to watch it, frankly. But you know, I took that as just gratitude for everything that's been done in the vaccine development, not just us, but and other vaccines as well. And the fact that vaccines have been rolled out so effectively by the NHS, by the vaccination clinics. There have been lots of volunteers involved in the clinics giving the vaccines, as well as the clinical trials. And people at vaccination clinics often get quite emotional about coming to receive their vaccine. And so we know there is a real huge amount of feeling about it. I mean, I suppose, given the very rare adverse events, that does temper the joy from our side. You know, we that is something that we have to address, and we're working very hard to do that. You know, we couldn't have known that was going to happen, but it did, and that is something that we still need to work on. But I think the public's realised that vaccination is the way out of what we've been living through, and so they're very pleased to have it.
Mm-hmm. And of course, thousands, millions of people in the country have contributed in all manner of ways to help each other during this pandemic. But I guess both of you and everybody involved in your team, and as you say, the wider volunteers, people being volunteering to be vaccinated and so on in trials, they've all contributed. But nevertheless, both of you have led an endeavour that has been life-changing, life-saving for potentially millions of people. And that just isn't something that most people can say in their lives. So is that something you're going to be talking to your grandchildren about? Is it something you feel proud about now?
Proud of my team, proud of the people that stepped up, humbled from the responses that we get. We get nice emails, little notes, people send us a thank you. A lovely email from a lady who sent me a little video of her mum doing a limbo dance at her granddaughter's birthday party, saying she didn't think she'd be able to do that this year. And now, because of the vaccine programme, not just ours, yet the vaccine rollout, all of it, she's limbo dancing with her granddaughter again. That's really emotional, yeah? Because we all have a little bit of that in our lives. And without it, there would be, you know, perhaps 30,000 grandfathers who are with us today that wouldn't be with us, according to the Public Health England data. So, yeah, but it's Sarah and I don't think it's down to us. We were in the right place at the right time to deliver what was needed with the right people behind us to get us across that line. That's
a humble way to put it, and I'm sure people watching appreciate that. You're also specifically now role models for women, for maybe young women starting out in science and research, and also kids. And I know you're going into schools now talking to kids. How seriously do you take that? Because there obviously is a problem with women going into STEM subjects, science, technology, etc., and believing that they can do it, they can succeed, and actually finding a way to navigate the system. All of that's tremendously difficult. Is that something now that you take very seriously as a result of your profile?
Well, yes, I mean, we want to inspire other people to think about careers in science. And I've been told that I had one email that said, you do realize it's not just the vaccine. Now all the cool kids want to do science, and the boys as well as the girls. And I think maybe science has taken a bit of a back seat in recent years. People haven't really thought about it very much, and they don't really understand the range of different scientific careers that there are out there. And one of the things that we talk about in the book is, the diversity of our teams, people trained and skilled in lots of different ways and all working together. And that's the real joy of doing science, I feel, is when you get to know a bit about lots of different parts, and then it all starts to fit together, and you work with colleagues who've got different skills and manage to make progress and manage to make a vaccine by bringing all of this together. And it's just really, really interesting. That's what's always drawn me into studying science. Is I just find it absolutely fascinating. And biology is a bit messy. If you do maths, you can be sure of your numbers and sure of your answers. If you get into biological systems, they don't always work 100%. So it's a bit more interesting, a bit more complicated sometimes. But we can use the biology to do useful things, and that's what we're doing when we're making a vaccine. So there's so many interesting careers you can have in science, and I'd really like to encourage people to think about going to a scientific career.
Yeah. I have a question here from Max, who asks, what advice would you give to early career researchers? So maybe someone who has a doctorate, a DPhil, perhaps not even at that stage. How should they try to succeed in academia and ensure that their research translates into real clinical solutions? Just a little question for you, Kath.
That's a big question. Science is a great career, yeah, but it's always going to be challenging. So if you're going to do it, you've got to love it. Find a question that you're really interested in. Find a topic that you love, and a supervisor who will help you get to that passion and drive for doing interesting things. The translation is much harder, and I don't necessarily like the idea that we're supposed to be focused on translation. Some time ago, somebody was doing some really esoteric adenovirus research, and from that, Sarah ends up with a platform that she can develop vaccines on. Yeah. So the person who first of all started studying adenoviruses was not expecting that to be the platform technology that we delivered across the world this year. So the idea that we can already know what will be translatable is, I think, not true, and we have to make sure that government funding schemes and that we have ability to do basic research, studying stuff because it's interesting, is also a great way for us as a community and as a species to learn new things that then can be applied in new ways. So I don't like to limit ourselves only to stuff that we can know now will be a biologically meaningful discovery. If that is what you want to do, there are lots of opportunities to find clinical translation research groups that will help you do that. But I don't want to limit ourselves to that as scientific endeavour.
Hear to that. I have a question perhaps for you, Sarah, from Abigail, who asks, what message would you give to those who are vaccine hesitant? What would you say to people who are reluctant or frightened of buying into the science? They're fearful to have this vaccination.
Well, I would ask them what their concerns are. What is it that they're worried about? It's natural to be worried about the unknown. So let's talk about what it is that you don't know and what it is that worries you. We have explained in the book at some length, how the vaccine's made, how it works, the fact that it doesn't stay around for long. It's not going to change you permanently. It's not going to change your genetics. It's a technique. Vaccination is something that's been used since Edward Jenner's day to eradicate smallpox. We've never got rid of smallpox without the vaccine that Edward Jenner worked on, and at one time that killed 1 in 3 of the population. So we tend now to think about vaccines as something that we give to young kids, and rarely think about them so much for adults until we get into flu vaccines for older people. Possibly there's a kind of gap in the middle years where people are not really used to being vaccinated, and that's partly because the diseases that we control with vaccines are so effectively controlled that we don't see them. We don't see the deaths from measles and the horrible consequences that you can have from mumps infections anymore, because the population is so well vaccinated. So what I'd say to somebody who's hesitant is, what is it that you're worried about? Because we can talk about what's actually going on.
Thank you. It is almost 8 o'clock, but I have so many fantastic questions. I'm going to ask a few more from the audience, if you don't mind. Now, this is a really topical one from Francis. I'm going to ask you this, Kath. So management of a whole team must have been crucial to the success of the whole project. So who was Gareth Southgate, or was that role shared?
Oh, you see, that's a tough question. There were 6, so principal investigators, there were 6 of us that originally came together to figure out how we could deliver the entire project. So it's Sarah's baby. Sarah's designed the vaccine. She's the one who's kicking us off, getting us going. And I'm the manufacturer, so I'm going to make it. And then Sandy is going to figure out how we make lots of it. Tess is going to do the immunology, and Andy's going to run the clinical trial. But if we're going to do on physical appearance, it's definitely Andy Pollard. But there were 6 of us in the back room sorting out the coaching, the fitness, all of it. We're a team. We don't have a Gareth. Though if Gareth wants to come and assist us next time, none of us are going to turn that down. Because no.
I think it's very important we get that invitation to Gareth. I feel if Gareth turns up in your lab, I feel you'll be mobbed by the people of Oxford. There'll be a frenzy.
There would be a frenzy. We had Prince William, but these days, sorry, Wills.
Yeah, he's no Gareth. Anyway, this is a question for both of you. Each of you in turn, after this extraordinary experience of producing this vaccine, what have you learned in hindsight?
That we weren't well enough prepared, and we could have been better prepared, and we need to make sure we learn the lessons of that for next time. It's about particularly its vaccine manufacturing infrastructure, which is something that nobody was ever interested in previously, and nobody ever really thought it mattered. And it's quite expensive, and it's quite complicated, and we really need it if we're going to be able to do this kind of work better and faster in the future.
Yeah.
Kath.
And those lessons around pandemic preparedness on a society level.
Yeah.
That shouldn't have been taking us by surprise, the impact it had on our society very rapidly, and certainly put in place better support measures for people who need to isolate, better track and trace. I mean, all of these things that we know aren't working so well. Come on, we've got what, 10 years, 20 years, 30 years till the next one. We could start using some of the knowledge about how do we protect the vulnerable while also ensuring that we can continue to maintain some of the basic requirements for functioning society. We can do the vaccines, and science will continue to deliver new modalities for making vaccines, for getting it done faster. I think we will start to see investment in places that we say. So Sarah was talking about vaccine manufacturing, very close to my heart, but hopefully also in research and development in some of the basic underlying research that we need to do. I think that I'm hopeful that we will continue to push for that funding to come. And then global joined upness, learning from other countries, learning not to be apportioning blame, but to try and work in a global situation as a global community, because we know this, nobody is safe until all of us are safe. And so it's no good us on our island being okay by August if the rest of the world is not. So we have to join all of it up. It's not going to be easy to do. Somebody's accused me of the last chapter of the book being my cash version of like Glorious Utopia, where we figure it all out and everything's fine. No, these are big questions that we need to be asking of our politicians and our policymakers and of ourselves as societies going forward. It's not easy. There's a lot to learn.
Absolutely. Very quickly, there have been a number of questions about variants, new variants, and obviously there's a lot of fears around those, and I guess in the back of many of our minds is the awful fear that what if there's a variant that none of the vaccines are effective against. So is that something you are proactively planning for? How are you dealing with this issue of new variants arriving all the time?
Well, just quickly, we started working towards that at the end of last year. started, because the technology we use is very adaptable, we can make a vaccine against any of the new variants, but it does take some time to get those made and into clinical testing. We're again trying to reduce the amount of time it takes. There's a clinical trial that's already started with one of the new variants. But we're also seeing that they're not really so different from one another, at least at the moment. And the original vaccine is giving a very high level of protection against the variants already. And just giving a booster dose with the original vaccine increases the protection across the board as well. So we don't think at the moment that we're really going to have to rely too much on making lots of different versions of the vaccine, but there's always the possibility that new variants will arise in future. And that's why it's really important to get vaccines out to the whole world now to stop transmission, because if the virus isn't being transmitted between people, it doesn't have the opportunity to mutate and form new variants. So that must be done as soon as possible. Otherwise, we are at risk of more new variants arising that may eventually be even more difficult to control.
Thank you. I want to close now by thanking you both so much for this evening's event, and I suspect I'm speaking on behalf of everyone here when I also say thank you for the work that you and your team have done over the last 18 months and the years preceding that, all the hard years of graft that enabled you to generate and develop this vaccine so quickly. I think we are all incredibly grateful, not just to the two of you, but everybody in your team and all the volunteers around that. Thank you, because you have done something remarkable. I'm going to hold up this book again. It is absolutely brilliant, and I want everyone watching to go out and buy it if you haven't got a copy with your ticket already. It is superb. This book is what science is really like as it unfolds, with all the lack of snacks in the vending machines, the crises, the problems. It's messy. It is not eureka driven. It's an extraordinary account of real life science as it unfolds. And it has both of your characters in it as well. And that is to the enormous benefit of the book. It's wonderful. So I want to say thank you very, very much, both of you, indeed, everybody here, for taking part. And I will hand back over to Blackwell's now. Thank you both so much.
Thank you.
And thank you from me as well to all three of you. It's been really wonderful being able to sit and listen to your conversation for the last hour or so, and hear a bit more about the story behind the vaccine. It's been a really brilliant event this evening. So thank you so much, all of you, for giving us your time this evening. As Rachel mentioned, we do still have some exclusive signed copies of Vaxxers available. If you haven't already got one, or you would like another one perhaps for a friend or family member, I've popped a link in the chat where you can go and order that. Or indeed, if you're based in Oxford, we do have signed editions in the Oxford branch only. So you can just pop in and pick one up in there if you're interested. We have a few more events coming up over the summer. We're very lucky that we are starting to trial in-store events again. So do go to blackwells.co.uk/events for just to check out the upcoming range of both virtual and in-store events that we've got coming up. But for now, thank you so much, Rachel Clarke, for hosting a wonderful conversation this evening. Thank you, Sarah Gilbert and Kath Green, for sharing your story with us and talking to us so generously. Thank you to everyone at home for watching and for your excellent questions. And I hope to see you at another Blackwell's event very soon. Thank you very much, and good night, everybody.
Thank you. Good night.
Bye-bye. Thanks.